Hi everyone, welcome to my channel. In this video lesson, I'll be showing you how to approach questions on finding the number of subatomic particles in an atom. So we shall be looking at the scholar's approach. Before we get into questions, I would like to show us some key points and formulas we have to have at the back of our mind before we can comfortably solve questions that has to do with number of subatomic particles. Now, what are these formulas we must have at the back of our mind? Now, looking at this, I said for an uncharged atom, emphasis on uncharged. That is, the atom we are talking about, which is represented as X, does not carry a charge. Now, if this is how the atom looks like, with no charge, now we know this will be the what? The atomic mass, or we say the mass number. And then we know the Z as what? The proton number, or what we say the what? Atomic number. So if this is an uncharged atom, how do you get the number of proton? How do you get the number of electron and the number of neutron? These are the formula for it, provided the atom is what? Carrying no charge. Number of atom is given as Z. That is, the number here is equivalent to the number of what? Proton in the atom. Number of electron is the same as the number of what? Proton. So Z and Z. And that's the reason the atom is said to be what? Uncharged. Now next, to get the number of neutron, it's simply the up minus the down. That is the mass number minus the what? The atomic number. That will give the number of neutron that this uncharged atom has. Now that aside, what if by chance the atom that was given to us was carrying a charge? We call it C, a charge. It could be positive charge, it could be negative charge, or whatever magnitude. How do you now get the number of proton, electron, and neutron? The formula will quite differ from that of what? Charged and uncharged atom. Now for a charged atom, the number of proton remains the same as Z. That is the number at the bottom here. While the number of electron will be Z minus charge. That is proton number minus the charge. Or you say atomic number minus the charge. This minus this. Then lastly, for number of neutron, it still remains up minus down. That is mass number minus the proton number. So these are the formula I want to take on at the end of this video lesson, okay, on finding the number of subatomic particles. This formula should go with you, whether it's your JAM exam or CUTM exam, or even your senior secondary school exams. You should have this at the back of your mind. So let's approach some what? Questions under this very topic. So here we are now. Let's get started, guys, without wasting time. Solution. Let's read the question together. They said, calculate the number of proton, electron, and neutron in 1. Let's get started. 1. What was mentioned? Ca is calcium. Ca is for calcium. So we write it Ca 40 and 20. This was what they gave us. Now, how do you get the number of proton, electron, and what? Neutron for calcium carrying a mass number of 40 and an atomic number of what? 20. Because, emphasis, because this guy is carrying no charge here, there is no charge, it means the formula we'll be using for this are these ones. These are the formula we'll be making use of. Okay? I always emphasize the importance of keeping formula at the back of your mind, because once you know the formula to the question, you can comfortably solve the question. So let's see how we can get the number of proton in calcium that was given here. Now, based on the arrangement, this guy here is our A. True, right? Here is our Z. Since there is no charge, that's why nothing is here. So number of proton, like we were given in the formula, number of proton is equals to what? Z. So we simply come and check which is Z here. The answer is what? 20. So we say number of proton is equals to what? 20. We are done with the first question for number of proton. The next, number of electron in this same atom. What is the formula for number of electron? E is equals what? Z. So whatever is Z is the same as the number of electron. So therefore, number of electron will be equals what? 20. I will come here and write 20. I hope we are following. The last thing for number of neutron, the formula will differ. It's up minus down. That is the mass or atomic mass minus the what? the proton number. So I will come here and write A minus Z. A minus Z. So what's our A? 40 minus 20. So this is 40 minus 20, and that gives us what? 20. So in calcium, in an uncharged calcium atom, I said uncharged calcium atom, the number of proton is 20, number of electron is 20, and the number of neutron is what? 20. So we are done for this. Let's quickly get to the next one. Mind you, this is going to be a different one. Let's see what it is. Now the atom here is sodium, but it's carrying a charge. So let's write it out. 2311 Na plus. Same thing we are going to be looking for. The number of proton, electron, and neutron. That's the same thing we'll be doing for this guy. So let's write P. Now, first thing first, ask yourself, is this guy carrying a charge? The answer is what? Yes, plus 1. That's what is here. Now, because it's carrying a charge, we have to be careful of the formula we use here. Now, we go straight to the guys that involve charged atom. For a charged atom, the number of proton is what? Z. That is the guy here. We'll come here and check. What is our Z? Here is A and here is Z. So what is our Z? 11. So therefore, the number of proton in a charged sodium atom is what? 11. Next, without wasting time, is E. How do we get our electron number? Because this guy is carrying a charge, we'll make use of the formula for electron number in a charged atom. And what is it? Z minus C. So whatever is our Z minus our what? Our charge. This will now give us 11, which is Z, minus what? Plus 1. And this is what we have. To further solve this from here, we'll say it's equals to 11 minus times plus. Minus times plus is equals minus. So minus the one that comes after it. Are we together? Good. Then when you minus 11 minus 1, we get 10. So the number of electrons in a charged sodium atom is what? 10. Lastly, for neutron number under this, the formula still remains A minus Z. So whatever is our A, we'll minus Z from it. Okay? A here is 23. While Z here is what? 11. So guys, 23 minus 11 is simply what? 12. Is it not? So the neutron number in this guy is what? 12. Now that is for question 2. Let's lastly treat question 2. Remind you, question 2 is carrying a negative charge. So the process will kind of a little bit be different. So let's get started. For number 3, they said 14,7 nitrogen carrying a minus 3 charge. We are asked to look for the proton, electron, and neutron number in this guy. So without wasting time as usual, let's get started. P will be equals to what? First thing first, is this guy carrying a charge? Yes. What is our A? 14. What is our Z? 7. Can we now get our proton number? Now from the formula, proton number is equals Z. So whatever is Z should be what? Proton number. So here is equals 7. Can we now get our electron number? Electron number is equals proton number minus charge. Now let's be cautious here. How we are going to do this? Watch out. Now if you observe, Z is 7 minus brackets. I always like to put it in the brackets. This is minus 3. And these are the writings in form of a charge. But it's equivalent to what? Minus 3. So I'll come here and write minus 3. Then I will close the bracket. Guys, how do we move further from here? Watch out. This will be equals 7. Now, from mathematics, minus times minus will change to what? Plus. So I'll come here and write plus. Then what number comes after it? 3. Here I will write 3. So guys, 7 plus 3 is now what? The answer is what? 10. So this is what we have as the electron number in this atom. Lastly, we are going to watch out for what? The neutron number. So we say N here is equals, like I said, the formula for neutron number does not change. Is the A minus Z. So come here and write A minus Z. And what's our A, guys? A is 14. And what is our Z? Z is what? Check it out. 7. So write 7, guys. Now, guys, 14 minus 7 will simply give us what? 7, 7, 7. It means the neutron number in nitrogen, this type of nitrogen atom, is also what? 7. So we mark it. So guys, this is how easy it is on how to what? Calculate the number of what? Subatomic particles in an atom. This is the overall process. So in concluding today's video class, I'll be dropping for you guys some questions to work out on this same topic. So do well to try your hands on it while I drop it now. Alright guys, these are the questions you should try your hands on. Okay? Now what are the questions? I said calculate the number of proton, electron and neutron in 1. This is magnesium carrying a 2 plus charge, or you say plus 2. Now the atomic mass here is 24, while the proton number here is 12. Now number 2 is 99 fluorine carrying a minus 1 charge. So do well to try your hands on this question and let me know in the comment section what you think the answer is. Don't forget, most importantly, to share this video with your fellow friends and classmates so they can also learn how calculating of subatomic particle is done. Thanks for watching. I remain Pides. See you in the next video.